In this video, we're going to be talking about three different scenarios and how they affect the gravitational force acting on it. We will look at how we can find the gravitational force and how the formulas differ between the three scenarios right here. The first scenario we're going to look at is body on Earth's surface. In this diagram, we have two circles. The big circle represents Earth, while the small circle represents the body on the Earth's surface. Now we know that Earth has a very large mass, so we will denote it as big M, while the body has a smaller mass, a much smaller mass compared to Earth, we denote it as small m. And usually when we are discussing mass of a planet and a mass of a body, or when we are discussing two masses that are very different, one is much bigger and one is much smaller, to denote it as one is big M and the other is small m. In order to find the gravitational force, we go force equals to gravitational constant, big M, which is the mass of the Earth, small m, which is the mass of the body. Instead of writing m1 and m2, we just denote big M as the mass of the Earth and the small m as the mass of the body over big R square. Now what is a big R square? It's just the radius of the Earth. Now why do we calculate the radius of the Earth? We remember that gravitational force acts between the center of the first object and the center of the body. So since the center of the body and the size of the body is really small, we neglect the length of the center, but the radius connects the center of the Earth all the way to the body right here, since the body is on the surface. So we use the radius of the Earth, and this is the final formula you get. So again, gravitational force equals to the big G, the gravitational constant, big M, which is represented as the mass of the Earth, small m, which represents as the mass of the body, over radius of the Earth square. Now let's just add some values and do a very simple example related to the formula given right here. Let's say the mass of the body is 70 kilograms, while the mass of the Earth will always be the same amount since the mass of the Earth doesn't change. The mass of the Earth will be 5.98 times 10 to the power of 24 kilograms. So I'll just write it at the side here. Mass of Earth, the big M, equals to 5.98 times 10 to the power of 24, 6.38 times 10 to the power of 6 meter, and the small m, being the mass of the body, equals to 70 kilograms. And knowing all this information right here, we can find the gravitational force, which will be big G. I'll just put the big G value here as well. 6.67 times 10 to the power of minus 11. So we know big G equals to 6.67 times 10 to the power of minus 11 times mass of the Earth, which is 5.98 times 10 to the power of 24, times small m, which is 70, mass of the object, over the radius of the Earth, which is 6.38 times 10 to the power of 6. And once you calculate, you will get a value of, just a quick correction, that you have to put the radius squared right here. And when you calculate, you will get 685.94 Newton. Now if we look at this, now that we know the gravitational force acting on the body from the Earth's center, another way to find the force acting on the body, this is an extra tidbit, is to figure out, or is to use F equals to mg. If we have F equals to m, which is 70, and g, which is 9.81, you will get a value of 686.7 Newton. Notice that both numbers are very close. I want you to keep that in mind, because in the coming video we will relate both equations to find the gravitational acceleration. But for now, just know how to calculate the gravitational force when the body is on Earth's surface. In the next video, we'll be talking about Earth and satellite, and I'll see you then.